Hello everyone, welcome to the lecture. Myself Devananda Rao, working as Associate Professor in the Department of CSE, MLR Institute of Technology, Hyderabad. Today's topic is examples of DFA. Construct DFA that accepts set of all strings over alphabet A, B of length 2. Here, the given alphabet is AB, input alphabet, and the length of the string is 2. So, valid strings are AB is a valid because length of the string sequence of 2 symbols, and BA is also valid, AA is a valid, B is also valid. So, BA, any string formed with the symbols AB should be of length 2 only, not more than 2. So, the DFA will accept a set of all strings whose length is 2. The set of strings of the string will contain symbols A and B, combination of A and B, but the length should be 2 only. For that, we need to understand what are the invalid strings. Invalid strings are, for example, A, B, because length is 4, invalid. A, B is also invalid because length is 3, and epsilon is also invalid because epsilon is 0 occurrences of symbols. That means the length should be 2, should not be 3, 4 or epsilon. 1 also invalid. This is also invalid. This is also invalid. So, for that we need to construct DFA. DFA having 5 tuple Q, sigma, delta, Q naught and F. Q is set of final states, sigma is input alphabet. Here the sigma is given alphabet is A, B, and delta, that is Q cross sigma to Q. Q naught is the initial state. F is the set of final states. This is the definition of the DFA. For that, we need to draw that state diagram, transition diagram for this DFA. The initial state is Q naught. So, for initial state, a small arrow coming towards the state representing initial state. See, from initial state, I can go to next state for input either A or B. See, first symbol may be A or may be B. So, the string begin with A or the string begin with B. Also, the string begin with A and end with A. Begin with B, end with B. But the length should be 2 only. So, from Q naught, by reading a symbol, any symbol A or B, I can go to Q1. In state Q1, that means I have read first symbol, either A or B. In Q1, if you read one more symbol, either A or B, I can go to final state. Q2 is the final state because I have seen 2 symbols, the combination of A and B, the string containing 2 symbols. So, that the string should contain exactly 2 symbols, the length should be 2. In Q2, so for every state you have to define the transition. For Q naught, I have defined the transition for A, I have defined the transition for B also, because two symbols are there in the alphabet. We have to define transition function for all the symbols for every state. For Q1 also, I have defined transition for A and transition for B. The function, transition function applied for A and B also. For Q2 also we have to apply transition function for A and B. But in Q2 is the final state, we have seen two symbols. If you read one more symbol, that becomes either A or B. If you read either A or B in Q2, that becomes the length is greater than, that indicates the length of the string greater than 2. So that I can go to another state, that is non-final state. Q2 is the final state. Okay. Q2 is the final state. That is, I have seen two symbols, two consecutive symbols. The length of the string up to Q2 is even, that is 2 only. After Q2, if you read one more symbol, either A or B, I can go to next state, that is non-final state, because if the string length is greater than 2, you should not stay in Q2. If the string length is exactly 2, you can stay in Q2, because Q2 is the final state. After processing the input string, if you stay in the final state, that indicates the string is accepted. You have to define transition function for A and B for Q3 also. Once you see third symbol, the length of the string is greater than 2. After that, you can read any number of symbols, either A or B. You can stay in the same non-final state Q3, because you cannot come back to Q2, because already we have seen the string that is greater than 2. So, like that we can draw the transition diagram or state diagram for this. So, Q indicates number of states in the DFA. How many states are there? Q0, Q1, Q2, Q3. 4 states. Total given states Q0, Q1, Q2, Q3. 4 states. Input alphabet is Q, A, comma, B. Final state. What is the final state? Final state is Q2. So, F is set of final state, that is Q2. Q2 is the final state. Then, after drawing transition state diagram, now we have to draw the transition table. The transition table contains rows and columns. For each input symbol, one column is defined. Input symbols are A and B. For each state, we have each row containing a state, representing a state. Q0, Q1, Q2, Q3. Q0 is the initial state, Q2 is the final state. So, Q2 is the final state. In state transition diagram, we can represent final state by drawing a circle and initial state with a arrow, small arrow coming towards the state. So, this column indicates state. This rows indicates states, column indicates input symbol. Now, the transitions. This is the transition table. In this diagram, from Q0 for input A, I can go to Q1. From Q0 for B, I can go to Q1. From Q1 for A, I can go to Q2. From Q1 for B, I can go to Q2. From Q2 for A, I can go to Q3. From Q2 for B, I can go to Q3. Once you reach Q3, for any symbol A or B, stay in the Q3. Like that, we can draw the transition diagram and transition table. This is the transition diagram. This is the answer for this example problem. Next problem. Construct DFA that accepts set of all strings over alphabet AB of length greater than or equal to 2. Here, the valid strings, the given alphabet is sigma is AB. AB. Valid strings using A and B are, the length should be greater than or equal to 2. The string length should be greater than or equals to 2. The valid strings are A, 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 B, A, B, and so on. The string should be, these are the valid strings. Valid strings. Invalid. Invalid strings are epsilon, because the length of the string should be greater than or equals to 2. A is invalid, B is invalid, those are invalid, because length is 1, length is 1, length is 1. So, length should be greater than or equals to 2. AB is also valid, AA is also valid. For this, we need to draw the transition diagram for the DFA. I will take a state, initial state as A. A is the initial state. First symbol either A or B. There is no restriction on the first symbol. You can read either A or B. I can go to next state B. Second symbol either A or B. There is no restriction for second symbol also, but length, restriction is on length. For epsilon, for string with single character length 1, I cannot go to final state. So, that A is a non-final state, B is also non-final state. But after B, if you read any symbol either A or B, I can go to final state, because I have seen two symbols. I have seen two symbols. The length of the string up to C is 2. After C, any symbols, third length of the string is 3 is valid, length of the string is 4 valid, length of the string is 5 valid, up to infinity, any length. So, that you can read any number of symbols of A or B stay in the same state. C is the final state. Okay. The transition table A, B, C, input symbols A, B. A on A going to B, A on B going to B, B on A going to C, B on B going to C, C on A going to C, C on A B going to C. So, this is the transition table. So, DFA definition, DFA formal definition, M is equals to Q sigma delta Q naught F. Here Q set of states, A, B, C are the states, A, B, C are the states. Sigma input alphabet, A, B. Delta is a transition function, Q cross sigma to Q. Q naught, initial state is A. Final state, set of final states, only one state, that is C. The A is the initial state, C is the final state. Now, we will see the string acceptance. String processing. String processing, I will take a string here. Delta is a transition function applied on state and input symbol. State is, initial state is A. For example, take any string whose length is greater than or equals to 2, A, B, B. So, now applying transition function for A, state is A, input is A, because the first symbol is A. So, state is A, input is small a. So, A on A going to B. So, the state is changes. So, A on A going to B, state is changes. Remaining input is A, B, B. Next, applying the transition function on state and input symbol A. B on A going to C, state is changes. Remaining input is B, B. Next, applying transition function on C and B. C on B going to C, input is B. C on B going to C. C on B going to C. C is the final state. C is the final state, so that string is accepted. This is string processing or string acceptance. This is about second problem. Third example, construct DFA which accepts sets of all strings over sigma AB of length less than or equals to 2. So, input alphabet is AB, the length of the string should be less than or equals to 2. Less than or equals to 2 means valid strings are epsilon is valid because 0 occurrence of symbols, empty string is less than or equals to 2, and A is a valid, B is a valid, AA is a valid, AB is a valid because length is 2, 2 is also valid, less than or equals to 2, BB is a valid, BA is a valid, like that. Invalid strings are AAA, AAB, AAA, any string whose length is greater than 2 is invalid. These are invalid, these are invalid, these are valid. So, here epsilon is also valid string. How can we go to final state without any symbol? Epsilon is empty string, no symbol, input symbol, empty string, no occurrence of symbol. How can we go to final state? How can transition occurs? That is why initial state itself final state. So, Q0 is the initial state, epsilon should be accepted, valid string. So, that initial state itself final state. Okay. Then, single character A or B is also valid, that is string length is 1, that should be also valid string. So, that the first symbol is either A or B, first symbol is either A or B, I can go to next state Q1. The string with single characters, the string with one character, string of length 1 should be valid, should be accepted. So, that Q1 is also final state. Epsilon is valid, string with one length is valid, string with 2 is also valid. So, from Q1 by reading either A or B, I can go to next state Q2. But coming to invalid strings, if the length of the string is greater than 2, that is 3, 4, 5, any length, that means if you read one more symbol from Q2, that is invalid length. So, that I can go to next state, that is not final state Q3. Once you reach Q3, that means I have seen strings of length 3 greater than 2. So, from Q3 for any symbol A and B stay in the same state. Then transition table as usual, rows columns containing indicating input symbols A or B. States Q0 is the initial state, Q1, Q2, Q3. Q1, Q0, Q1, Q2 are the final state. Q0, Q1, Q2 are the final state. Q0 on A going to Q1, Q0 on B going to Q1, Q1 on A going to Q2, Q1 on B going to Q2, Q2 on A going to Q3, Q2 on B going to Q3, Q3 on A, Q3 only, Q3 on B, Q3 only. This is the transition table. Transition table. This is transition diagram. Then we will take one string, valid string, or first I will take valid string, that means delta of A, that is string processing, delta of A comma AB. Q0 is the initial state, Q0 comma AB. AB is the string of length 2, 2 is a valid string, Q0 is the initial state. So, delta is a transfer function applying on Q0 and A, first symbol is A. So, Q0 on A going to Q0 on A going to Q1, remaining input is B. Now apply Q1 on B, delta transition Q1 on B going to Q2. Q2 is the final state. So string is accepted. Next, I will take an invalid string example. String processing. Delta function, initial state is Q0. Take invalid string of any string with length greater than or equal to 2. AB, AB, AB. Here the length is greater than 2. So that the string should not be accepted. Delta Q0 on A. That is Q0 on A going to Q1. Remaining input is B. So this is over. Remaining input B, A, B, A, B. Next, Q1 on B. Q1 on B going to Q2. Remaining input is A, B, A, B. Next, Q2 on A going to Q3. Remaining input B, A, B. Q3 on B. Q3 only. Remaining input A, B. Q3 on A. Q3 only. Q3 on B. Q3 only. Q3 is the non-final state. Non-final state, so that string is not accepted. So as usual, DFA definition M is equal to Q sigma delta Q naught F. Q is number of states, 4 states, Q0, Q1, Q2, Q3. And sigma is input alphabet AB. Next, delta is a transfer function Q cross sigma to Q. Q0 is the initial state. Next, F is the final state. Final state is set of final state, not one state, more than one state, that is Q0, Q1, Q2. This is the example for DFA which accepts set of all strings over sigma AB of length less than or equals to 2. Create a DFA which accepts set of strings of even length. Even length. Even length means string with 2 symbols, that is length 2, length 4, length 6, length 8, length 10 and so on. Epsilon is also because 0 number of symbols. For this, the DFA will be initial state itself final state. A is the state, that is we are assuming epsilon is also string of even length. If you read any symbol, the length will become odd. If the length is odd, either A or B, if you read A or B from A, state A, I can go to next state B, that is non-final. So that is, if you read either A or B, that becomes odd length. If you read one more A or B from B, it becomes even. So that I can go to. This is the state diagram for this transition table as usual. A, B, Q, state is A, B. A on A going to B, A on B going to B, B on A going to A, B on B going to A. A is the initial state as well as final state. So this is DFA definition. M is equals to Q. M is a machine, DFA machine. Q sigma delta Q naught F. Q is set of states A and B. Sigma is AB, input alphabet. Delta is a transition function Q cross sigma to Q. Q naught initial state, that is A. F set of states is A final state. This is the example. Next, create a DFA which accepts strings of odd length. Odd length means 1, 3, 5 like that. The string length should be odd. Take initial state, If read any symbol, initially no symbols, that is even. If read any symbol either A or B, that becomes odd. So, odd number is accepted going to final state. If read one more A or B in final state, that becomes even number. So, that I can go to non-final state. If read one more A or B in A, I can go to B because it becomes odd. Whenever if you read symbol by symbol, whenever it becomes odd, I can go to final state. Whenever it becomes even, I can go to non-final state. Transition diagram: A, B. A is the initial state, input is A, B. A on A going to B, A on B going to B, B on A going to A, B on B going to A. String processing. Delta, initial state is A, take any string with odd A, B, B. A on A going to B, state B, remaining B, B. B on B going to A. A on B going to B. B is the final state. A, B, B accepted. Because string length is odd. Thank you.